Does carbon dioxide absorb more light than nitrogen? Yes, carbon dioxide, CO2, absorbs more light than nitrogen, N2. CO2 is one of the greenhouse gases in the atmosphere, and it absorbs light at specific wavelengths more strongly. CO2 molecules tend to absorb light in the infrared spectrum, which causes the greenhouse effect associated with global warming. On the other hand, N2 molecules are primarily present as nitrogen gas in the atmosphere, and they do not play a significant role in absorbing light in the atmosphere. N2 molecules, along with oxygen in the atmosphere, transmit most of the visible and infrared light. Therefore, CO2 and N2 have different abilities to absorb light, and CO2 is particularly important in regulating the Earth's temperature as a greenhouse gas. This is one of the key scientific principles related to climate change and the greenhouse effect. Specifically, CO2 molecules absorb infrared light with wavelengths of 13 to 19 micrometers in the atmosphere. This wavelength of light includes heat emitted from the Earth's surface. When CO2 absorbs this wavelength of light, it makes it difficult for heat from the Earth's surface to be re-radiated back into the atmosphere. This causes the greenhouse effect, which raises the Earth's temperature. On the other hand, N2 molecules are the most abundant gas in the atmosphere, and they are composed of 2 nitrogen atoms. Because nitrogen atoms have fewer electrons, N2 molecules absorb less light than CO2 molecules. N2 molecules primarily transmit visible light and some infrared light. Therefore, CO2 and N2 have different abilities to absorb light, and CO2 plays an important role in regulating the Earth's temperature as a greenhouse gas. Do water molecules absorb light? Yes, water molecules absorb light at certain wavelengths. Water molecules tend to absorb light in the visible and infrared regions. In particular, water molecules absorb light in the infrared spectrum, which causes water to create dark bands in the infrared spectrum. This light absorption phenomenon plays an important role in chemical, environmental, and meteorological research. The absorption of light by water affects a variety of natural phenomena related to temperature, climate, and humidity in the atmosphere, and such research plays a key role in the fields of earth science and environmental science. So does water vapor in the atmosphere affect global warming? Yes, water vapor in the atmosphere plays an important role in global warming. Water vapor is one of the greenhouse gases, and greenhouse gases in the atmosphere trap some of the heat that escapes from the Earth, raising the Earth's temperature. This is called the greenhouse effect, and the increase in the concentration of greenhouse gases above a certain level can contribute to global warming. Water vapor is one of the most important greenhouse gases. As the temperature rises, the air can hold more water vapor. So the concentration of water vapor in the atmosphere also increases during the warming process. This increase in water vapor concentration contributes to global warming, which is related to climate change. Water vapor also works with other greenhouse gases such as carbon dioxide to regulate the Earth's temperature and influence the formation of climate. Therefore, water vapor is one of the major greenhouse gases that has a significant impact on global warming and climate change. Additional information. 1. The amount of water vapor in the atmosphere is determined by the temperature and humidity of the air. 2. Water vapor is a major component of clouds, which also play a role in global warming. 3. The absorption of light by water vapor is a complex process that is affected by the temperature, humidity, and composition of the air. 1. The amount of water vapor in the atmosphere is determined by the temperature and humidity of the air. 1. As the temperature rises, the air can hold more water vapor. 2. Water vapor is a major component of clouds, which also play a role in global warming. 2. Clouds reflect sunlight back into space, which helps to cool the Earth. 2. However, clouds also trap heat, which can contribute to global warming. 3. The absorption of light by water vapor is a complex process that is affected by the temperature, humidity, and composition of the air. 3. The amount of light that is absorbed by water vapor depends on the wavelength of the light, the temperature of the air, and the humidity of the air.